all we can do is factor the denominator, and the denominator factors to x plus 2 squared. That's going to affect your end behavior of the vertical asymptotes. All right, we have factored it. I do not have any holes. There are not any binomials that cancel out from the top and the bottom. V stands for a vertical asymptote. So for the vertical asymptote, I only have one, but y'all, what is the end behavior of this vertical asymptote? Very good, same, write that down. Horizontal asymptote, you compare the degrees. That was that yellow box that I put up. Is there a horizontal asymptote? Look at your degrees. There is. Y'all have a horizontal asymptote. It's the x-axis. Do you have an oblique asymptote? Yes, I'm sorry. I was trying to write that and this. Y'all, I apologize. What's your oblique? There's none. If you guys have a horizontal asymptote, you're never going to have an oblique. So there's none here. What about a 0? Do you have an x-intercept? You don't. How do you know that, Michael? You're right. On the top. Yes. No x on the top. None. Can we have a y-intercept? What is the y-intercept? So remember, we'd plug in zeros for those. On the bottom, 1/4, 1/4. All right, it's time to graph. Let's do this. All right, so just going back to the top of my list, we only have one vertical. Horizontal. Y'all bold out that y-axis. All right, so after the asymptotes, you plot your dots. How many dots am I plotting? Just one, that's right. The y-intercept is the driver of the whole problem. Is it above or below the origin? That means that I have some graph floating up there. So I'm going to go ahead and take care of that. All right, so just barely above, like right there. Then I have a branch up here. No doorway to go to the other side. All it can do is hug asymptotes. That's all that branch can do. On the other side, we wrote same. So if I drew an up arrow on that side, I have to draw an up arrow on that side. There's no doorway. This branch is just going to hug the asymptotes. And that's it. And hopefully you guys recognized, y'all, when we factored that, that was the quadratic reciprocal in transformation form. It was just 2 units shifted to the left. There it is. Domain, I almost forgot. Domain. Negative infinity to -2. And just pick it up, y'all, to positive infinity. So I'm going to go out of order. I want to make sure we have plenty of time to cover holes. So what we're going to do next is we're going to do example number 4. Please find example number 4. And then here we go, y'all. It is the sentence. What letter do I write first? Hold on, I'm going to test you guys. Sophia. What letter do I write first? Then what, Sebastian? Then what, Kayla? This is hard, slow. What's next, Clayton? Torin? Savannah? Neil? Nick? Kayla? Did I pick on you twice? Did I say your name twice? Yes! I got to pick on you. All right, cool. Then, y'all, do as much as you can without me. You're going to have a hole. You're going to have a hole. So, what cancels out now? Which one cancels? Yes. So, I'm grabbing my red pen. I'm canceling them out. But what number do I write here? Awesome. All right, so what are we working with? Remember, don't look back. No rear view mirror in this. So we're going to take that 2 and just find the y coordinate. What's the y coordinate? Yeah, 3/2. I'm totally cool with you writing 3/2. I'm cool with you writing 1.5. Just don't write 6/4 because we have to simplify it. Okay, no looking back. So we're just focusing on this guy right here. So look at it. You got one vertical asymptote. You got one x-intercept. So for the vertical asymptote piece, I'm going to write x equals a -2, opposite behavior. Do you have a horizontal asymptote? Look at what you wrote down today. It's 1. It's 1. The degrees equal, so just divide out the leading coefficients. They both have a coefficient of 1. So y equals 1. And guys, please remember, if you have a horizontal asymptote, you're not going to have an oblique at all. Where is this graph going to cross the x-axis? At the -4. What kind of behavior is going on with that? That's your vertical. Just straight through. One side to the other. One side to the other. Your y-intercept, it's just going to be 4 divided by 2. So your y-intercept is just a +2. All right, let's graph. Any questions on that? All right, so what do we know? We know we have a hole. So your hole is at 2 3/2. If you're using the packet, you can count. If you're sketching like me, just kind of estimate where it is. A +2 and a 3/2. Exaggerate that hole. Make sure we can see the paper through it. Use your red pen. All right, I'm also going to draw my vertical asymptote, which is a -2. Opposite behavior. I've got a floating horizontal asymptote, one place above the origin. All right, I'm going to plot those dots. We just have two dots. We have a -4, 0, passes straight through. We got a y-intercept floating above the origin. And that's it. So look, you got a doorway. You're going to be hugging the asymptote. You're going to cross through to the other side. Then you're going to just hover right underneath your horizontal asymptote. That's it. Do you have any questions? Are you sure? Domain. I totally almost forgot again. All right. So domain, what are you going to block out? You're going to block out two things now. -2 and +2. You got that hole to think about. You always block out vertical asymptotes and holes. How many dots did you plot? There's only one. There's only one. So listen, why? What does this graph not have? It certainly does not have a y-intercept. That's impossible. You just drew a red line through the y-axis. All right, let me plot my dot. What is the dot? +3? Okay, so again, you can do sign analysis. You can do sign analysis, it would not matter. You can totally do it. Or you can remember what happens when you have a positive A value on the right side of the graph. It's up, which means your outputs are getting higher and higher and higher. But watch. Think about asymptotes. Think about the behavior of an asymptote, guys. So if it goes up, then I know it's going to go something like that because the A value is positive. It has to be on the upper side right here. You got asymptotes. So this graph isn't going to just, like, it's not going to do that because it's closer to this horizontal asymptote. So you're going to have a branch shoot off and it's going to hug the horizontal asymptote. So it's going to look like this. My outputs are certainly getting bigger. My outputs are positive. In between these two vertical asymptotes, you're going to have a U. It's either going to be a U down here or a U up above. Is the U above or below the origin? It's above. Good job. All you're going to do is just hug the asymptotes.